myself Dr. Anuj Purwar. Today we will discuss about the sources and collection of water part 2. Collection of surface water. Whenever water is withdrawn from a surface source such as lakes, rivers or reservoirs, and entrance of the withdrawal conduit is not an integral part of a dam and other water retaining structure, then an intake structure is constructed at the entrance of the conduit. Hence, an intake is a structure constructed at the surface water source to facilitate the conveying of the water to the treatment plants either by gravity or into a sump when pumping is required. Factor governing the location of an intake. The intake is to be located as near as possible to the treatment plants so that the cost of conveying water to the treatment plant is minimized. It should be located around a relatively clear zone of the source so that load on the treatment plant is minimized. Arrangement at intake should be provided such that elimination of silt and floating matter is possible to a great extent so that they may be prevented from the entering the conduit. The intake site is to be free from sources of all type of contamination. The location should be such that it can draw water from the source in all season. The site should be free from currents and should be founded on stable ground. The intake should be located such that its lowest silt level can be kept below the low water level of the source. The location should be such that water may be drawn to the treatment plant by the method of the gravity. Now, components of the intake. A water intake consists of the following components: intake structure, a conduit with protection work, inlets, screens or gratings, gates and valve to regulate flow. Here, design consideration of the intake. There should be multiple inlets to the intake conduit so that there is at least one submerged inlet during the period of low water level. All the opening to the inlet must be provided with screens to avoid the entry of large solids and floating matter. Sufficient openings must be provided to intake structure at different intervals in different direction to avoid formation of eddies around it. The foundation of the intake structure must be taken to sufficient depth as to reach to the firm ground, having adequate bearing capacity and no chance of differential settlement more than permissible value. Both upstream and the downstream portions of the bank near the intake must be protected against erosion by rip-rap. Inlets to the intake should open to the downstream side of the structure, or they must be at right angles to the direction of flow in case of a river or a wide canal intake. Now, types of intakes. Depending upon their position with respect to water, intakes are primarily constituted as submerged intake and exposed or tower type intakes. Here the submerged intakes. A simple submerged intake consists of a simple concrete block or a rock-filled timber crib supporting the intake end of the withdrawal pipe. Here we are in this picture we are seeing the intake. This is submerged in the water and some well is available to collect the water from this submerged intake, and in this submerged intake having the bar screen to reduce the possibility of entering the some pollutant materials. And this is the tower type intake. Here the water available at the higher level intake or not submerged in the water. So they are also known as the exposed intake. They are tower-like structure. This type of intake is used for tapping water from reservoirs, lakes, and most commonly for rivers. It has got greatest advantage that the water can be drawn at any desired level. Now the classification of river intake. Intake well. They are circular, masonry or concrete tower 2 to 6 meter in diameter provided on the bank. The water flows into the intake well through the penstocks located at different levels. Penstocks can be operated from the operation platform at the higher level. This type of intake is provided for rivers which have sufficient flow through the year. Pipe intakes. When a small quantity of water is to be drawn, the pipe intakes are the economical. A required number of intake pipes are laid across the river bed. The pipes are supported as masonry blocks at regular intervals. The ends are provided with strainers and anchors firmly by masonry blocks. The pipes carry water to a well known as jack well. Weir intake. Water is drawn from the weir through a channel into a sump well. For rivers which are more or less dry in summer, a weir is built across the river to the required height to store excess flood waters during the rainy seasons. A channel is provided from the river to the intake well from where water flows by gravity or is pumped as the case may be. Floating pontoon intake. In case of wide rivers with great fluctuation in flow, weir intakes are not economical. In such case, floating intakes with a strained well mouth are provided. The well mouth is protected by a floating crib. The position of the well mouth and the crib is located at a place in the river where water is available in all seasons. With the variation in the water level, the floating crib also rises or falls accordingly, thus ensuring water supply during lean period. Lean period means low water level. So here the picture showing the floating pontoons intake. A platform is floating platform is there, and the intake pipes are submerged in the water, and water is collected in this way. Groundwater. Water precipitated upon the surface of the earth is disposed of in three ways: by evaporation, by surface flow, by percolation. Percolating water that passes beyond vegetation pass on downward in obedience to the law of gravitation until it reaches an impervious layers of some kind. The accumulation of water which exists in the ground is called groundwater, and its top surface is known as the groundwater or groundwater table. Factors favorable for transmission of the groundwater. Igneous rocks are usually dense and impervious, hence poor water carriers, but sometimes they furnish considerable water due to their decomposed and fissured condition near the surface. Sedimentary rocks composed of very fine grained materials such as clays, shales and other argillaceous deposits are relatively impervious. Limestone and dolomite contain little water as a rule, but if fissured, they contain considerable amount of the water. The most favorable formation for furnishing large quantity of water are sandstone, conglomerates, sand and gravel deposits. Uncemented sand and gravel are the most favorable, but they are limited in extent. Influence of geology on groundwater. The content of meteoric water with geologic strata in their downward percolation provides opportunity for pollution and purification as well as for solvent action. Since the organic matter of the topsoil is continuously undergoing oxidation with the concomitant production of carbon dioxide, it is natural that percolating water contain gases in solution. Contact of this carbonic acid laden water with lime, magnesia and ferrous iron lead to the solution of these substances. Iron containing sands yield iron bearing water. Water traversing limestone strata usually contains good concentration of these limestone minerals. Water flowing over and through igneous formation frequently contain little mineral matter. The greater the distance through a given formation water has traveled, the greater will be its mineral content. Now, springs. Springs are formed where groundwater is caused to overflow upon surface. The conditions causing their formation are varied, hence to be carefully studied for design of collecting works, because upon them depends consistency of flow, the possibilities of increasing yield by suitable works and probable success of a search for additional springs. As per differences in these conditions, springs are classified into three general classes. So here the picture showing the formation of the spring water, how the spring water comes out. First class of spring. The most important class of springs is that in which the water in its lateral movement is brought to the surface at the outcrop of a porous stratum where it is underlain by a relatively impervious gravel or a porous rock, whereas the impervious layer is clay or rock of an argillaceous character. If the porous material is fairly uniform, the spring will be scattered all along the outcrop and is small in size. The yield of springs of first class vary with the variation in groundwater level. The yield of a series of springs of this class would be equal to the entire percolation. Now, second class of spring. Under this class, those springs are considered where water bearing stratum is covered to a greater or less extent by an impervious one, and therefore more or less they are artesian in character. In this case, water finds its way to the surface where the overlying impervious material is absent or through a fault, or it breaks through it at places where it is not sufficiently strong to compact to resist the upward pressure. Springs of second class are likely to be affected to a lesser extent by variation in rainfall. Their yield varies with variation of the groundwater level in the area of percolation. Now, third class of spring. Under this category, the are springs in which porous stratum in the vicinity of the spring is neither overlain nor immediately underlain by an impervious one. They are simply overflows of the groundwater and occur whenever the carrying capacity of the porous material is sufficient to convey the tributary flow. The yield from third class of spring have great fluctuation. The flow sometimes ceases entirely. Characteristics of the spring water. Springs may yield comparatively soft water or hard water depending upon the materials encounters in its underground passage. This water is not necessarily pure, neither they possesses any special health giving characteristics in most of the cases. In some cases, the water passes through the underground sulfur zones, and in such case, hot water spring is obtained, which sometimes has curative power from the skin disease. Artesian water. An artesian well may be defined as one in which the water is drawn from a porous stratum underlying a relatively impervious one and so located that the contained water drawn from a distant elevated outcrop exert more pressure upon the overlying cover. The total yield of an artesian shore may be limited either by the rainfall and percolation on the outcrop or by carrying capacity of the stratum. Infiltration galleries. The underground traveling water can be intercepted by digging trench or by constructing a tunnel with holes on sides at right angle to the direction of flow of the groundwater. These underground tunnels used for tapping underground water are called infiltration galleries. The yield from the length of the infiltration gallery depending upon ground condition. For maximum yield, galleries should be placed at the full depth of the aquifer. Here the picture shown for the infiltration galleries. Here one side is the river or stream is available, and there is a ground level is available, and the groundwater table is shown in that picture. So the infiltration gullies are constructed, and in that case water flows in that way. There is a hose available, and in that way waters flow in that gallery. And this is all about the lecture on the sources and collection of part 2. In next lecture we will discuss more numerical problems on the source and collection of water as a source and water and collection of water part 3. Thank you.